Okay, in this video, I started with getting some of these things out that we're going to reference. So this table, again, I've drawn many times, and kind of the just start of the unit circle, so them 4 points. So we talked about how to graph sine. So y equals sine x, no transformations. It starts at 0, it ends at 0, and it's periodic, right? It takes 0 to 2 pi. So when I say ends at 0, at 2 pi is the period, and it ends at 0, the function value is 0. And then we have, it follows this curve, and it's periodic, so, we can continue, right? Both directions. To quickly fill in y equals sine x, that's going to be in the way actually, here in a second. Let me write it here. I also know the max value is going to be 1 and then negative 1, and if I write these 4 angles from 0 to 2 pi, right, if I just broke up 2 pi into fourths, then I'd have a half, a 1 pi, a 1.5 pi, and 2 pi. I could quickly fill in sine x. And then reverse it, right, continue this periodic function in the negative direction to get sine. Cosecant. So first off, I'm going to give you the graph, and then we'll talk about y really quick. To graph cosecant and secant, I will always graph sine and then picture where cosecant would lie. Because once you have this, anywhere the value for sine is 0 is going to be an asymptote. Again, I'll explain why in just a minute. Here's just how you can quickly develop the graph. And then it looks like a whole bunch of parabolas going off of the max and the min in between those asymptotes. So in this baby blue that I drew, and it would keep going, I'd have, what appears to be a bunch of little parabolas. That is the graph of cosecant x. And then I would erase the sine. I would erase sine because it's not both of the graphs. Trying to erase without erasing all my info here. A little bit got erased, that's okay. So this was negative 2 pi, that was negative pi over 2. Okay. So the graph of cosecant does not include the graph of sine. But if I graph sine in there, I can quickly see the graph of cosecant by drawing in my asymptotes. Asymptotes are just lines that graph will never cross, or in this case, vertical asymptotes. And draw these parabolas from the max and min values along that periodic function sine x. Now I'm going to go ahead and throw it back in there because I want to talk about some of these values and explain what's going on here. Okay. So remember, cosecant is the reciprocal of sine. So cosecant is the same as 1 over sine x. Notice at 0, sine is 0. So cosecant, right, at 0, we'll go ahead and squeeze it in here, would be undefined. Because I would have 1 over sine, so 1 over 0, that doesn't work, right? Undefined, and hence an asymptote. So at 0, I drew in that asymptote. All right, let's go ahead and continue on. The reciprocal, so 1 over 1/2, is 2. The reciprocal of square root of 2 over 2 is going to be, well, let's go and draw it really quick. So 2 over root 2, right? And then I multiply by square root of 2 over square root of 2. And we just get square root of 2. Okay, and in fact, we could have pulled that directly from the unit circle or special angle, but that's all right. All right, and now pi over 3 would have 2 over root 3. And then that would need simplified, so 2 root 3 over 3. And then the reciprocal of 1 is just 1. Now here's what I wanted to point out, though. The values as we tend to get to this pi over 2, which is right here, right, where we got 1, are getting smaller and smaller. I had 2, then square root of 2, which is like 1 point something, and then 2/3 of square root of 3. I don't even know what that is, but I know they're getting smaller and smaller. Remember, sine got larger and larger till we hit to 1, so if I do the reciprocal, they're going smaller and smaller. So what does that mean? Well, these values, as we're going, oops, that's a highlighter, right, to this value pi over 2 are getting smaller and smaller until we hit 1. So why does it do this now? Again, you could picture this graph. Each of these values, we're doing the reciprocal because it's less than 1, right? Like I could even just make up a number. Somewhere right here is like 7/8. So if I do that reciprocal, I'm at 8/7, right? I have 1/2 somewhere in here. So if I do that reciprocal, I'm at 2. I have 1/8 somewhere in here. So if I do that reciprocal, I'm at 8, right? I'm way up there. All of these values here, the reciprocal, because they're between 0 and 1, are getting larger and larger until we hit pi, which would be another undefined point. And why is that? Because it's 1 over sine, right? And if sine is 0, then I would have 1 over 0, which is undefined. Same thing works in this negative direction. All these values, right, if I do the reciprocal, they're still getting larger and larger, but in the negative direction. Somewhere in here I'd have -1/2. Now I have -2. Okay, and that continues forever, right? Because the domain for sine is -2 pi to 2 pi. So what about domain and range for cosecant then? Well, for domain, we have problems at every pi, right? X cannot be 0, it cannot be pi, it cannot be 2 pi, it cannot be 3 pi, and so forth. So I'm just going to say x cannot be n times pi, where n is some natural number. Well, it could be negative as well, so we'll just say n is an integer. That z means it's an integer. It can't be negative pi, it can't be -2 pi, cannot be 0 pi, and so forth. The range, remember sine was in between -1 to 1. This is actually everything but that. When we erased that sine function, we actually had -infinity up to -1. Oops, parenthesis on infinity. Union, it can be 1 or -1 though, infinity. All right. Well, by the same logic, cosecant will follow. So cosecant, I know, starts at 1, and that 1 full revolution, 1 full period, it ends at 2 pi. And then if I kind of think, all right, to get here and end here, then in the middle, it'll hit -1, and then these two would be the zeros. Okay, that's how I quickly graph sine and cosine without having to really think about any of those values. Excuse me. Okay, so now similar algebraic reasoning, but I'm just going to sketch it really quick. Anywhere there's a 0 is an asymptote because I would have 1 divided by 0. Okay, anywhere there's a max, right, at 1, I'm going to draw on that parabola going up. And anywhere there's a min at -1, I'm going to draw that parabola going down. And then I would just erase cosine. Oh, I missed that last one. That's okay. Okay. And now I have my graph of secant, which is 1 over cosine.